Good afternoon, everybody. Can you all hear me? Okay, oh well then, this is not such a big lecture theatre. Welcome to this year's summer school. It's my pleasure to introduce to you this afternoon Associate Professor Shadreck Chirikure. He's in the Department of Archaeology here at UCT. He's quite well known in his field. Shadreck completed his PhD in archaeology at the University College of London. His doctoral thesis explored the technology and socio-cultural metaphors associated with pre-colonial iron production in northern Zimbabwe. He has two broad research interests, namely artifact studies and heritage management in contemporary Africa. He combines archaeological, anthropological and historical approaches with standard metallurgical and mineralogical techniques to investigate pre-colonial metal extractive technologies. He will explain to you what all that means. You can decode the code for that. And it's associated socio-cultural processes. Currently, his research in this field is on indigenous mining and metallurgy in southern Africa. He is also actively involved with research on heritage management in contemporary Africa. Shadreck is quite widely published. He has recently published 2015 Metals in Society, Indigenous African Metallurgy in a Global Perspective. In 2010, he also published Indigenous Mining and Metallurgy in Africa by Cambridge University Press, and together with other scholars, Peter Delius, Esterhazen, and Skuman and Mlazi, Mapungubwe reconsidered. I give you Shadreck. How is it? But just put it on English. Okay, well, if you feel it, put your words.
Hello. I wish I was a DJ, then I would say 1, 2 for testing. Anyway, good afternoon, everybody. The wonders of books. Look at what I saw in the foyer. I'm not saying that I'm yearning for the deep past or something like that. It's just that I'm an archaeologist who deal with very old things, and I happen to come from a country called Zimbabwe, which used to be called Rhodesia, by the way. Anyway, today I'm going to be talking about a subject that is very interesting for me, and it's also a subject that is controversial, particularly in the context of the present. How many of us do not have metal on us today? Metal, just in general. Can we survive without metal? The fact that nobody is answering perhaps suggests that it's something that angers all our lives. So what I will be doing today is sketching with a fairly broad brush the history and beginning of metalworking, particularly in the Middle East, and then with a heavy emphasis on Africa. So I have organized this series of lectures according to themes. Today, I will talk mostly about origins. When did metalworking begin, when and where, and with what consequences. And then tomorrow, I will give a detailed and focused case study, particularly mining and metallurgy in ancient Egypt, as well as the Middle East. And then I will move on to West Africa, as well as Southern Africa, and then give a concluding overview. So today is just a general overview, which is aimed at just emphasizing some key and essential points in the development of metallurgy. One of the things that we might need to bear in mind is that of all the metals that are known today, probably before the 18th century, it was at least 14, 15 that were known. And not surprisingly, people talk of the metals of the 7 metals of ancient civilizations. And I will also speak to that. So we owe a lot to the Industrial Revolution. Most of the metals that we have today. So aluminium, for example, which requires very high temperatures to smelt. It was one of the outcomes of the Industrial Revolution. So perhaps for us to understand the significance of metallurgy today, without arguing that metallurgy would have had a similar impact in the past, it is important to just flag a few issues as a way of contextualizing the significance of mining and metallurgy in human history. So one way of looking at it is what would the world look like without metal today? Structural engineering, transportation, and everything. What would be the nature of those things? And can we do without metal? Since everything from utilitarian objects to expressive materials, so if you like bling, earrings, and stuff like that, that's all metal. And virtually all the world's eminent civilizations, from the Middle East to China to Latin America, Mesoamerica, and so on, they are also based on working a metal. So the beginning of metallurgy actually initiated long-distance trading networks, particularly across the Middle East, extending into China, extending into Europe, and extending into parts of Africa. So globalization, as we know it today, we can trace it back to the need to work metals. So the emergence of centralized states, governance, centralized governments, and so on, it can also be attributed partly to the onset of metalworking. The Industrial Revolution is actually a culmination of cumulative advances in mining and metallurgy throughout the years. And even today, the South African economy is still, to some extent, based on mining and metallurgy. So that is something that is important to us today. But perhaps what we are interested in today is what do we know about the history of metallurgy in the world? So it's also interesting that John Compton is here, because this contradiction, which I am flagging here, on the one hand, the earliest evidence of mining is from Africa. So a number of places in the Southern Cape, Pinnacle Point, Blombos Cave, and related places. So the earliest exploitation of pigment, hematite, which was used as ochre by Middle Stone Age populations, has been dated to about 120,000 years ago. But the earliest evidence of mining with intent to process the ores to gain a usable metal is something that started very, 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 very late. And depending on where you are in Africa, in Southern Africa, it started around... It's nice acoustics though. It's nice acoustics. So in Southern Africa, the earliest evidence of metalworking dates to AD 200. In Egypt, that's around 5,000, 6,000 BC. In West Africa, that's around 1,000 or 2,000 BC, depending on who you read. The evidence tends to be quite controversial. So we have to realize that in as much as the evidence for mining has been dated to a very early time period in Africa, mining with a metallurgical goal in mind is something that is very, 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 very recent. So beginning around 2,000 years before present, if one is to use a generous estimate. So here is a timeline of the beginning of metallurgy in the world. So perhaps a question that is important to ask at this point in time is that for roughly 99.5% of human history, human beings were using a stone to make tools. And they were using both utilitarian, expressive, and so on. So the actual exploitation of metal is something that is recent if we consider that very long history of humanity. But, so the question here is that why the change from stone to metal? If, as I'm saying, for a larger part of human history, people were making stone, and even in the recent past, there are still some populations that use stone to make tools, which means that stone is really effective. So why the change? And when do we start seeing that change in the archaeological record? According to the American scholar Cyril Stanley Smith, he argues that the beginning of metallurgy, particularly in the Middle East, in places such as central Turkey, Anatolia, and surrounding regions, he argues that the beginning of metallurgy had nothing to do with practical functions at all, but it had everything to do with colors, with utilitarian, with expressive purposes. So Cyril Stanley Smith argues that the beginning of metallurgy actually owes a lot to humanity's fascination with colors and later on with sound, because according to him, stone was actually a very effective raw material for making tools. So some of the clearest evidence of humanity's encounters with minerals that bear metal when reduced or smelted dates to around 10,000 years before present at places such as the archaeological site of Çatalhöyük, where Ian Hodder and colleagues have been carrying out research, and that's in central Turkey. So at archaeological sites in that region, there is evidence that during the Neolithic, human beings were looking for copper ores such as malachite and azurite, and they were shaping them to produce green beads or blue beads if it is azurite. So that is the very first use of these copper carbonates or copper oxides. They are used as glass beads, as part of necklaces. So 10,000 years before present, there is no evidence that human beings are intentionally smelting copper ores to produce metal for a wide variety of purposes. Slightly later than that, maybe 900, 800 years before present, depending on who you read, there is also evidence that some populations in modern-day Bulgaria, Serbia, and thereabout were also working gold to produce, again, beads. So gold existing in its native form in nature, it does not require any smelting. So that would explain why it would have been used. So again, we need to emphasize the fact that according to some scholars such as Cyril Smith, the earliest use of metal perhaps owes a lot to the colors, to the sound, and he is convinced that it had nothing to do with utilitarian purposes. Part of his reasoning comes from the fact that around around 800 BC or thereabout, we begin to see the evidence that human beings were exploiting native copper, which is copper in its natural state. So native copper is widely available in different places in the world. The Great Lakes region in the United States is actually one of the areas that is, so the area around Lake Superior or thereabout, there is quite a lot of native copper there. So there is evidence that communities in the Middle East, they were hammering at that native copper to produce implements. Nevertheless, the uptake of that technology was not really huge. So it's one or two items amidst a technology that was dominated by polished stone axes, the so-called Neolithic tools. It was only around 7,000 BC, based on current evidence, that cultures that are known by archaeologists as the Vinca cultures in modern-day Serbia, they, in addition to working native copper, they also started intentional smelting of carbonate and oxide ores. So the technology is still very, very, if we may use the word in quotes, very primitive, in the sense that if you have very rich carbonate ores, which do not have many accessory rocks, it would be easy to smelt them. So some of the researchers working in this region believe that so for one to smelt, you need a number of things. You need a source of heat, and also you need a source of air, and you also need the raw materials, which would be the ore itself. So throughout the development of metallurgy, we see people using bellows at different points in time. I will elaborate on that a little bit later on. But it is believed through experimental replication that during the beginning of metallurgy at this period, human beings were actually blowing the furnaces using the mouth. So you just have like a long reed, and then you blow into a fire. Tomorrow I will show you evidence of that, of those reconstructions from some of the tomb paintings in Egypt. So that is what is also being used to support that. And so from 7,000 BC, intentional copper smelting was well established at a very small scale in areas such as Serbia, Turkey, Iran, and perhaps Egypt. Then with time came what is known as the Bronze Age. So bronze is one of the most important alloys in the history of human civilization or the development of humanity. Bronze is a mixture of copper and tin. But what happened is that towards the end of the Chalcolithic or the Copper Age, so around 4000 BC, archaeologists start to see evidence of copper that is rich in arsenic. So the earliest bronzes were not tin bronzes per se, but they were what are known as arsenical bronzes. And it is debatable whether the arsenic and the copper were intentionally alloyed or it was just a result of coarse smelting. So if you were to smelt some arsenic-rich copper ores such as olivenite, you might actually come up with an arsenical bronze. So this is just an unintentional process. But with time, human beings would have learned about the benefits of that. Because if you add a little bit of arsenic or tin to copper, then it transforms, it enhances the properties, the workability becomes much better, the hardness, the resistance, and all the good qualities. And the Bronze Age is also the time period that some of the earliest civilizations, particularly in the Middle East, are developed. So 2000 BC, 2500 BC or thereabout, we are, if you believe in that, we are in the time of the Bible. So those stories in the Bible, occupation of places such as Jericho and so on, this is clearly in the late Bronze Age. So in terms of the world's, some of the world's earliest civilizations, the city-states of Sumer, such as Uruk and others, they are actually they were established during the late Bronze Age period. And also extending from the Middle East right up to China, around 2500 BC, we also see the first appearance of tin bronzes. So one of the most interesting developments during this time period is that, yes, if you add tin to copper, you create a very useful alloy. And how it works is that if you add, let's say, between 1 and 5% of tin to copper, you are going to have low tin bronzes, which also have some specific characteristics. But if the more tin you add, the more brittle the alloy becomes, such that around 1500 BC or thereabout, there are what are known as the Bronze Age mirrors. So human beings were adding, let's say, 30% tin to copper to create a very tin-rich bronze. But because it was very brittle, they would also polish the surface so that it reflects, and that was used as mirrors. And it's a technology that continues right up to the Islamic period. And there are some high tin bronze mirrors that are known from the Swahili sites along the East African coast. So this is a technology that goes back a long while. And during the late Bronze Age, particularly some of the burials from places such as Air, they also have some of the earliest evidence of earrings made of gold. So, and also some infrastructure for processing makeup and so on. So we can trace some of the cultural behaviors that we have today to that deep in the past. So I mentioned the fact that bronze is an alloy of copper and tin. The most interesting question then is that copper was widely available in the Middle East and the Mediterranean region. So Cyprus the island of Copper, and there are many other regions that were rich in copper. But tin is perhaps more geologically restricted. So it is believed that some of the tin that is being used in the Middle East and adjacent regions at this point in time was sourced from as far as Afghanistan. There is a ship that sank off the Mediterranean coast of Turkey around 1500 BC, so that's a long time ago. It had some of these tin ingots that are known as oxhide ingots, simply because the shape resembles like an oxhide. So that's where the name comes from. So those oxhide tin ingots, a number of researchers such as the Gales at Oxford, they fingerprinted the tin to Afghanistan. So the belief is that some of the tin that is being used by some of the early civilizations in the Middle East was coming from the Middle East. And there is also evidence that Africa was well integrated into this long-distance trade, because in the same Yulubrun shipwreck, there is also ebony, and which is believed to have been sourced from the present-day Sudan. So there are some commodities that are coming from Africa, some which are coming from Afghanistan, and this is evidence that a very established and viable long-distance trade network had been established at this point in time. Whilst perhaps my last point on this is that thefts and forgeries, they were also part of human beings during that, or back then, because the metal ingots that were found on that shipwreck that I mentioned, some of them, they had those seals, what we now call today trademarks. And some of those trademarks can be associated with known workshops in Cyprus and the other places. So what was happening back then was that the traders, unscrupulous traders, would, in the process of casting copper, they would take lead and then pour in a melt of copper around the lead, so that lead is very heavy. So that would inflate the weight of those ingots. So as a way of certifying that this copper is coming out of Shadreck's workshop, we first see what we might call today commodity branding, and that's 2000 to 1500 BC. So after the Bronze Age came the Iron Age, and iron, of course, the working of iron started with the processing of meteoric iron. So that's iron from the sky, in quotes, as others would describe. And the earliest evidence remains that Tutankhamun's dagger, which dates to around 1500 BC or slightly earlier, which is made of meteoric iron. But the intentional smelting of iron ores to produce metallic iron is associated with the Hittites in Anatolia, as well as the Assyrians. What is interesting is that in as much as iron started as a very prestigious metal, which was closely guarded, so to use a modern day analogy, it was like if you possess a knowledge of iron working, it's like you had nuclear technology. But obviously, with the time, there was a transformation such that by the time of the Greek civilization, iron was known as the democratic metal, simply because it was widely available and everybody could have it. But the most interesting thing was that Egypt was very, very, very conservative because it only adopted iron after 671 BC. That is when it was invaded by the Assyrians. And a number of archaeologists think that the reason why Egypt was defeated is because it didn't have any iron, such that at the beginning of iron working in Egypt is very, 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 very late when compared to its neighboring regions in the Middle East. And that explains part of the debate whether iron in sub-Saharan Africa came from Egypt or not, because the technology dates to almost the same time. But I'm going to elaborate on that. One of the highlights associated with the development of metallurgy is that around 600 BC or thereabout, there was a well-established system of coinage. So coins, copper coins, silver coins, they were well circulated in the Middle East as well as in the Mediterranean world. So such that by the time of the Roman Empire, coinage was well established. And actually, one of the amazing things, one of the most amazing things is that today we worry so much, we are concerned about pollution, but the pollution associated with the Roman Empire actually is still hounding people in modern day Jordan. That is, there is a copper mining landscape which is known as Fenan. The Romans had a very large-scale copper working industry there, but the copper ores from the Fenan region, they are rich in arsenic, and arsenic is poisonous, such that most of the burials that were recovered in that area, they've got very enriched levels of arsenic. And some studies that were done as recently as 2010, they showed that some of the goats that browse around that area, the modern day Fenan, they are also enriched in arsenic. And that's a legacy of the large-scale metalworking in that region during the Roman times. So one of the things to emphasize is that, yes, in very broad strokes, we can say that there is a copper age, there is a bronze age, and there is an iron age. But the periodization, it differs depending on where you are in the world. For example, if you cross the Atlantic, there was no iron age. And also, there are some amazing developments. For example, by at least 500 BC, the Chinese could produce cast iron, which was only produced by the West as a result of the Industrial Revolution. So there are so many developments that are taking place in India, in China, that I did not include here. So for reasons to do with time and to make it manageable, I just restricted my focus to the Middle East. But what you need to know is that there are also other interesting things that are taking place elsewhere, particularly in China and India. So all the developments that I was talking about from the Chalcolithic, from the Copper Age to the Iron Age, basically show that for the world's civilizations, we can talk of basically 7 metals. So gold, copper, silver, lead, tin, iron, and mercury. All the other metals that we can talk about, they are a result of much later processes. So that those protoforms of globalization that I was talking about, they were based on these metals. But the most interesting thing is that mercury was unknown basically in sub-Saharan Africa until after the Portuguese sailed around the Cape of Good Hope. And so there are massive differences. And then silver in regions such as Southern Africa, it was also unknown. So there are massive differences. But in summary, these are what are known as the 7 metals of ancient civilizations. So at this point, I'm now closing in on the situation in sub-Saharan Africa after that generalized introduction. So what we can say is that in regions such as the Middle East and surrounding areas, the working of metals started with fairly easier metals. So I mentioned gold, which exists in natural form in nature. I mentioned native copper. I mentioned meteoric iron. And then later on, the copper was smelted. The temperatures are not as high as the temperatures involved in iron smelting. And the iron smelting, which is regarded as a little bit complex, was only smelted after 1500 BC. So this is the trajectory that we see in the Middle East, the trajectory that we see in the Indian subcontinent, as well as in China and other places. So the big question is, what was the situation in Africa south of Egypt? Was it the same? Was it different? What was the picture? So at this point, let me just give a very brief overview in terms of the process technology, what is happening or what happens in terms of pre-industrial metallurgy. So you start with mining. So in this case, let's say, okay, that's iron. So extracting mining ores and then gathering other raw materials such as clay to make this furnace, and then charcoal, which acted as the fuel. Of course, the Chinese used coal from very, very, very early on, but coal, particularly in Europe, was something associated with industrial processes, and the same applies to Africa. So for most of this time, it was charcoal. So when all the raw materials were gathered, they were charged into the furnace. You can see somebody who is bellowing here. After about 3 to 4 hours, a series of these chemical reactions took place, with the result that a solid mass of iron was produced together with a molten iron silicate, which is also known as slag. So that was the process. Very different to the modern blast furnaces that we use today. This was direct this is also known as the direct process, in the sense that the metal was usable. In the blast furnace, it's indirect because, first of all, they produce pig iron, which is then decarburized to produce different grades of iron or steel, from wrought iron to whatever steel, depending on how much carbon is in the metal. So the iron bloom contained some charcoal. It was cleaned in a forge, and then it was then the smiths also made different types of objects. So this is basically a summary of technologies, but obviously, as we will see as the week progresses, each region had different approaches, but basically the apparatus, particularly the infrastructure here, was the same: a clay-built furnace and charcoal acting as a fuel, with different types of bellows providing the air to sustain combustion. And then the result were some of those products that were widely circulated. So this technology appears to be universal, but there are quite a number of issues, particularly when we talk about Africa south of the pyramids. The big questions are, where and when did metallurgy begin? And was it local or exotic? And more importantly, remember I mentioned that the dominant thinking is that in terms of metallurgy, one would start with the easier steps before getting on to more complicated technological processes. So is there a copper age in sub-Saharan Africa? And if so, do we have the evidence? And then Southern Africa, which is one of our regions of interest, how did metallurgy spread? So these are just some different places and well-known, some of the well-known sites and places associated with metalworking in Africa. We will see this map again. So I also have to state up front that the pattern in which the technology dispersed across the African continent is very difficult to comprehend. In some areas, there is more evidence. In others, there is less evidence, which is also complicated by the fact that in regions of Africa where there is conflict, not much archaeological research takes place. So because of Boko Haram, a very promising region in Nigeria has been abandoned simply because it's not safe. So the traditional view regarding the origins of sub-Saharan metallurgy is that sub-Saharan Africa borrowed its or got its knowledge of metallurgy from the Middle East, and then through processes of diffusion, the knowledge of metalworking then spread to the Sudan and further to the south, and then to West Africa. So this is the traditional view, and at some point it was based on the dating evidence. So these are some of the arrows that show the dispersal. We can also add some arrows from here because we know that there was metallurgical knowledge that was spread from Spain to regions such as Morocco, but that was after Phoenician occupation in this area. That is around in the early centuries, around 800 BC or thereabout. So in its early manifestations, this traditional diffusionist framework was, it argued that, it was based on those views that said, well, Africa has never invented anything, but it only received from others. So metallurgy was brought by advanced people from this region into Africa. And however, as scholarship, as more rigorous scholarship developed, there was a belief that sub-Saharan metallurgy began in North Africa, and then it spread to the other areas. Some of the reasons were technological, because according to David Philipson, to argue that Africa only started with iron and not copper is not logical. This is because perhaps I forgot to mention the point that whereas the picture in the Middle East is that there is the working of copper, bronze, and iron, in most of sub-Saharan Africa is iron and copper, and then bronze and gold. So it's the reverse. So the debate then is it possible to have an iron working technology without an earlier phase of working native copper or copper smelting? So that is where the debate is, and that is where David Philipson is coming from. And here he is saying that because the associated technology, that is iron smelting, is so complex, and in earlier African societies, no other process involved heating materials to such high temperatures, we have to consider the possibility of a northerly source of sub-Saharan iron working knowledge rather than duplicate independent discovery. So what Philipson is saying is that it's very impossible. We cannot say that iron working began in Africa simply because it does not match the trajectory in the Middle East. So these are some of the roots that knowledge of metallurgy would have been introduced to sub-Saharan Africa according to the external origins hypothesis. We're going to see this map again. But the most interesting thing is that some of the scholars based in Africa, such as Augustine Hall, they are arguing that there are a number of weaknesses associated with the external origins thinking. In particular, the fact that the dating of the earliest appearance of iron in the source areas of North Africa, so in this area here and there, the dates, according to Augustine Hall and others, is just the same as in these areas. So according to Augustine Hall, then, if we check our time, particularly on this map, which is his map, but actually, we can see that how do we explain the fact that if metallurgy here influenced the development of metallurgy in the Great Lakes region of East Africa, how do we explain the fact that it's the same time bracket? So this is one of the major challenges. And they also argue that there are massive technological differences, as we will see, between Egyptian furnaces, Phoenician furnaces, and some Moroccan furnaces when compared to the ones that are used in these different regions. So they are saying that perhaps this is evidence of local development. So initially, the local origins hypothesis started as an ideological response to frameworks that denied Africa any agency, any initiative. And they said that, well, Africa had multiple areas of invention. And as we can see, these are some of the areas that are believed to be the source of African metallurgy. So according to this framework, then, Sub-Saharan Africa does not need to replicate the picture that we are seeing in these different regions, because human beings can develop in different trajectories. There's no need to follow the same pattern. So part of the reasons is that obviously there are some activities that are happening here and there. It's just that this map reflects the general lack of archaeological evidence. But nevertheless, there are different types of furnaces, as we will see tomorrow, that were used to smelt iron. There are some what are known as tall natural draft furnaces that were at least the maximum height could be 4 meters. And those drew in air through inlets at the bottom using the principle of convection. So, and then there were these low shaft furnaces and ball furnaces. The air was introduced through bellows. So these are forced draft furnaces. And this is the diversity that we see on the African continent. So what are the proponents of the local origins hypothesis argue is that perhaps this diversity, which is not necessarily chronological, perhaps it attests to a local experimentation. So these are some of the furnaces. This is the Cameroon, just to give you an idea of the diversity. So that's the cross section of the furnace. This furnace could produce cast iron and some very high quality, high carbon steels. So that's one of the interesting examples of the local production of cast iron in sub-Saharan Africa. And then these are some of the natural draft furnaces, this time in Malawi. So these vents, those are the ones that sucked in air using the principle of convection.
How is it? But just put it on your case. Okay, well, if you feel it, then put your case.
Okay, so
Hello. I wish I was a DJ, then I would say 1, 2 for testing. Anyway, good afternoon, everybody. The wonders of books. Look at what I saw in the foyer. I'm not saying that I'm yearning for the deep fast or something like that. It's just that I'm an archaeologist who deal with very old things, and I happen to come from a country called Zimbabwe, which used to be called Rhodesia. But
Good afternoon, everybody. Can you all hear me? Okay, oh well, this is not such a big lecture theatre. Welcome to this year's summer school. It's my pleasure to introduce to you this afternoon Associate Professor Shadreck Chirikure. He's in the Department of Archaeology here at UCT. He's quite well known in his field. Shadreck completed his PhD in archaeology at the University College of London. His doctoral thesis explored the technology and socio-cultural metaphors associated with pre-colonial iron production in northern Zimbabwe. He has two broad research interests, namely artifact studies and heritage management in contemporary Africa. He combines archaeological, anthropological, and historical approaches with standard metallurgical and mineralogical techniques to investigate pre-colonial metal extractive technologies. He will explain to you what all that means. You can decode the code for that. And it's associated socio-cultural processes. Currently, his research in this field is on indigenous mining and metallurgy in southern Africa. He is also actively involved with research on heritage management in contemporary Africa. Shadreck is quite widely published. He has recently published 2015 Metals in Society, Indigenous African Metallurgy in a Global Perspective. In 2010, he also published Indigenous Mining and Metallurgy in Africa by Cambridge University Press. And together with other scholars, Peter Delius, Esterhazen, and Skuman and Mlazi, Mapungubwe reconsidered. I give you Shadreck.
Anyway, today I'm going to be talking about a subject that is very interesting for me, and it's also a subject that is controversial, particularly in the context of the present. How many of us do not have metal on us today? Metal, just in general. Can we survive without metal? The fact that nobody is answering perhaps suggests that it's something that angers all our lives. So what I will be doing today is sketching with a fairly broad brush the history and beginning of metalworking, particularly in the Middle East, and then with a heavy emphasis on Africa. So I have organized this series of lectures according to themes. Today, I will talk mostly about origins. When did metalworking begin, when and where, and with what consequences. And then tomorrow, I will give a more detailed and focused case study, particularly mining and metallurgy in ancient Egypt, as well as the Middle East. And then I will move on to West Africa, as well as Southern Africa, and then give a concluding overview. So today is just a general